Dear students, let us continue with the relativity. Okay, so in this class, we are going to study an important realization of classical mechanics, that Galilean invariance of space, Galilean invariance of time. So first one is Galilean invariance of time. Sorry, we will do first space as it is in the book of space. So just to explain you what is it means, suppose you have a stick 1 meter long, or let us say you have a stick, you are holding a stick, and you are on the, say you are on the bus stop, you are standing there, and somebody passes by, you have it, somebody passes by in a car at 60 kilometers per hour, let us say. Okay, you are holding a stick of some length, you only know that, and this fellow who is going in the car, your friend, will see the stick and he will tell you, yeah, I saw you in the bus stop, you were holding a stick of this length. Okay, then what you do is you measure it, and then what you will come to know is what your friend saw and what you measured, both are equal. Okay, so the space, or the space means the dimensions, length, breadth, height, the space looks the same. So you, even suppose if you are standing in a bus stop covering your face, okay, suppose in a different dress, your good friend will recognize you because you have got a, everyone has got a typical size and shape. Okay, we have a particular fatness, we have particular height, we have particular body structure. So your friend will definitely identify you even if your face is not visible, your dress is different. That is because the space looks the same even if somebody is traveling or somebody is stationary. So that is Galilean invariance of time. And another one important term or another concept is Galilean invariance of time. As I mentioned you, similar to space, time is invariant. Suppose some event happens, just like before, you are in a bus stop and somebody, your friend, is traveling by a car, and a person nearby claps his hand once, then he claps his hand again. Let us say he claps his hand in an interval of time. You measure the time between the claps. You can use your mobile phone and you can stopwatch. Using the stopwatch on the mobile phone, you can measure the time interval between the claps. So when first clap is heard, you start, and then when the second clap is heard, you stop. Same thing your friend will also do in the car. He will also measure the time interval. And what Galileo or classical physics says is the time measured by you and your friend is the same. Okay, the time between the two claps is the same. This might look obvious. What is new in it? Like space, Galilean principle of invariance of space, invariance of time. What is this? Is what we see every day. Why it is in the book? Okay. Just I'll give you a hint. This looks obvious because this is true in our day-to-day life, but this is not true always. When we go to high velocities, which we will study later in this chapter, in Einstein's theory of relativity, the invariance of space and invariance of time does not hold good. Okay. So with that, let us briefly discuss the concept of invariance of space. So for that, as before, always we need two frames of reference. One is O dash S frame, another S dash frame. Just you can recall, one is traveling with the velocity v, S dash frame, like a car moving, and then Z dash. There are 2 points, so we have to measure the distance. So this is XA and A point, B point, and this is XB, and this is X dash A, and this is X dash B. Okay, I will just put that here, dash B, and this is X dash A. These are just the distances. So you have 2 points. What you are doing is you are measuring the distance between A and B sitting stationary or while traveling. Okay, you are taking the 2 cases. So as before, we have to write, you can look it